Hello, grade 7. This is Mrs. Lopez. Today we are starting to learn lesson 16 in module 3 of the 7th grade curriculum. First of all, this topic C is a little bit different from what we've learned so far in the module 3. So far, we've known equations, expressions, and inequalities. And in topic C, we are jumping right into geometry. We are jumping into circles, finding surface area and area of circles and other shapes. So, but however, what we are going to do is very much connected to what we have been doing. And you will see with the time how it is connected. First of all, let's talk about circles. Circles are round shapes made up out of points, and every point is going to be the same distance away from the center of that shape. Okay, how do we draw a circle? We use a tool named a compass. This is the tool right here. Every compass consists of a pivot point and a marking point. Pivot point is that pointy end of that compass, and marking point is your pencil. To make a circle, in case here in opening exercise, we need to use the compass and need to draw a circle like the picture to the right. So what I want to do, I want to find a distance between the center of that circle and the edge of that circle. Okay, that is the distance. And I'm going to keep that distance right here. I'm going to keep that distance and draw exactly same circle. So take a look. I'm going to place the needle on a paper, and then I'm going to hold the top of my compass right here, and I'm going to rotate it, and so the marking point makes a shape of that circle. Mine is very slight, very light, but I hope you can see it. It takes some time, it takes some practice, but mostly by the time you are doing your third and fourth circle, you get the hang of it. Okay, so this is my circle. My circle is exactly the same size as the circle right here. It looks a little bit smaller, probably because of the camera, but we can check by looking at the distance from edge to the center, and this edge to the center are exactly the same. Okay, point C in this circle, in the one that is given to us, point C right here, is the center of the circle. So point C is the center of the circle. The center of my circle is going to be right here. It's very hard for you to see, but that's my center right here. That's where my pivot point was, where my needle was. That is the center. The distance between point C and point B is the radius of the circle. Very important word that you're going to use all the time in this topic is radius. Radius is this distance from this center to the edge of the circle. Radius. Radius can be drawn in any direction because, as I said, the distance between the center and the edge of the circle is always the same, no matter where you draw it. I can draw it here. I can draw it going up. I can draw it going down. It's going to be exactly the same because that's what circle is all about. Its points on that edge of the circle are the same distance away from the center. If I take again my compass and I look at that distance right here, I can go with that distance everywhere around my circle, and it's going to be exactly the same. That's what radius is. In fact, the distance between the pivot point and the marking point of your compass is the radius of the circle. Okay. All right. So in part B, it says write your own definition for the term circle. Again, circle is a shape. Let's write down circle is a shape um, where the points on the edge, the points that make the edge of the shape, where the points that make the edge of the shape are same distance, are same distance away from its center, from its center. When you know that radius can be drawn in any direction and it will be exactly the same number or exactly the same distance. Extend segment CB to a segment AB in part A, where A is also a point on the circle. So if I extend my segment CB so that I can draw another radius right here, and I will mark it point A. It's also going to be a point on the circle, and it's a segment AB now, right here. Okay, I can also extend my radius right here and draw um, another radius. Okay. The length of the segment AB is called the diameter of the circle. So AB is the diameter of the circle. And what I'm going to do, I'm going to write that right here. This is diameter of the circle. The length of the segment AB is called the diameter of the circle. The diameter is twice as long as the radius. If you look at this is the radius right here from the center out, and this is the radius right here from the center out. It takes two radii to make the diameter, right? So on the bottom of this page, we will write the diameter is twice as long as the radius. Okay. All right. So measure the radius and diameter of each circle. The center of each circle is labeled C. Okay. Um, so we are going to measure. I usually like centimeters when we measure something. It's more precise. And we can use decimals if you want. Measure the radius and the diameter. So if I'm taking this small circle right here and I measure the distance from A to C, I will get 1.5 centimeters. 1.5. Okay. And if I measure the diameter, so this is 1.5 centimeters. And if I measure the diameter, it will be exactly 3 centimeters. So diameter will be 3 centimeters. So see how the diameter is twice as long as the radius? Okay, let's take the second circle and measure the distance from point E to point C. That is 2 centimeters exactly, and diameter is 4 centimeters exactly. So radius is 2 centimeters, and the diameter is 4 centimeters. Let's take this circle right here. And here we don't have a radius and diameter drawn. You can though draw it and measure it because we know that anywhere I draw it, I can draw it right here. In fact, let's do it. Let's draw a segment that goes from the side of the circle to the center. That is the radius of your circle. And that radius is exactly 3 centimeters long. 3 centimeters. If I need to extend this radius to the other edge of the circle, I will get exactly 6 centimeters, which is twice as long, and that is going to be my diameter. So 6 centimeters. Okay. Draw a circle with a 6 centimeter radius. That's going to be a large circle, so get ready. The radius is 6 centimeters. So I'm going to look at my ruler and I'm going to take my compass. And since the distance in the compass between the pivot point and the marking point is my radius, what I'm going to do is to measure with the compass on the ruler right here 6 centimeters. Okay, that is my 6 centimeters. And that's what I'm going to do to use to draw my circle. So without changing the distance in my compass, I'm going to find any point on my paper and put the pivot point and draw circle. Here we go. Okay, the center of the circle is right here. That's where my pivot point was, and any point on that circle is going to be the same distance away from the center, and the distance from the center to the edge is going to be called the radius. The distance from the edge to the edge going through the center is going to be the diameter, where 2 radii can make the diameter. Okay, let's move on. Modeling exercise. The ratio of the circumference to its diameter is always the same for any circle. The value of this ratio, circumference over diameter, or circumference divided by diameter, is called the number pi and is represented by this symbol right here. This is pi. Pi without an e at the end. Okay, that's a Greek letter pi. Since the circumference is a little greater than 3 times the diameter, let's take a look at this. If I were to put a string over my circle, that string will be as long as just a little bit over than 3 times the diameter, okay, of the same circle. And you can try it at home. Find any circular object and measure it with a string around it, and then try to put that string over the diameter of that same object, and you will see that it goes a little bit over 3 times that diameter. Okay, and since the circumference is a little greater than 3 times the diameter, pi is a number that is a little greater than 3. Use the symbol pi to represent this special number. Pi is non-terminating, non-repeating decimal. Remember how in Module 3 in Topic B we were talking about repeating and non-repeating decimals? So this is it. This is a non-repeating decimal, pi. And mathematicians use the symbol pi or approximate representation are more convenient ways to represent pi. In this unit, in this topic, we are going to use 3 representations of pi. We will use it as a letter, pi. We will use it as a decimal, 3.14, 3 and 14 hundredths. or we can use it as a fraction, 22/7. Okay, these are the three representations that we are going to use. Very, very important. The ratios of the circumference to the diameter and pi are equal. Circumference of the circle is going to be found by multiplying diameter by the pi. What is the circumference of the circle? Circumference of the circle is the outside of that circle. That is circumference. You know how to find the perimeter of the shape, right? When we add all the sides. Well, circle does not have all the sides that we can add, but the perimeter, the distance around that circle is called the circumference. Distance around the circle. Distance around the circle. Okay, we can find the distance around the circle without measuring it. Sometimes we can have very different numbers here, but if we know the diameter of the circle, and if I know the pi, which is a constant number, which is a little bit more than 3, which is 3.14 or 22/7, or just pi, we can multiply that number, pi, by how long the diameter is. If I multiply diameter by pi, I will get the circumference, the outside of the circle. Okay, let's take a look and see how it is applied. Here's the example. The following circles are now drawn to scale. Find the circumference of each circle. Use 22/7 as the approximation of pi. So as I said before, circles can be different. So if you measure the circumference right now, it'll be a little very short, but we know that the diameter has to be 21 centimeter. That's more than the length of a ruler, okay, of my ruler. So it will be tricky just to measure it. You will not be able to get the right answer. What we want to do is to use this formula. To find the circumference, I need to multiply pi by diameter. I will put C as representation for circumference, and I will put D for diameter and pi for pi. To find circumference, I'm going to multiply the diameter. My diameter is 21 centimeters, 21 by, and they ask us to use 22/7 for pi. So I'm going to substitute 22/7 instead of that pi. 22/7. And I will do multiplication just as I do multiplication of fractions. I'm going to put 21/1, and I see that I can simplify 21 and 7 by 7. So I can divide 7 by 7, and I can divide 21 by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. So all I need to do right now is to multiply 3 by 22, and that will be 66 centimeters. That is how I find the circumference of this circle right here. To find the circumference of this circle, I'm going to do exactly as I did here, but now I'm going to use 91 feet as diameter. So I will take circumference equals, instead of diameter, I'm going to put 91/1, and I'm going to multiply that by 22/7. I can divide 91 by 7, and I will see that it can be simplified by 7 again, by 7. 7 divided by 7 will equal 1. 91 divided by 7 is 13. So now what is left is to multiply 13 by 22, and that is 286. and in this case, it will be feet. Okay, last circle right here, but and this one is tricky because we don't have the diameter. What we have is just the radius from the center to the outside, and the radius is 35 halves. Can I find diameter if I know the radius? Absolutely, because I know that the two radii will make a diameter. So I can either add 35 halves and 35 halves, or I can multiply 35 halves by 2. So to find the diameter, I need to multiply the radius by 2. R stands for the radius, D stands for diameter. 2 radii make the diameter. So to do that, I'm going to multiply 2 over 1 by 35 halves. I know that I can simplify 2 and 2, and I will get 35 in my diameter. Okay, so that is the diameter. Now let's find the circumference. Circumference is diameter times pi, and I will multiply 35 over 1, right, by 22/7. I see that I can simplify 35 and 7 by dividing both numbers by 7. 7 divided by 7 is 1. 5 divided by 7 is 5. So now I'm multiplying 22 by 5. And 22 multiplied by 5 is 110. And in this case, we have meters. Okay, that is as simple as that. The radius of a paper plate is 11 and 7/10 centimeters. Find the circumference to the nearest tenth. Use 3 and 14 hundredths as the approximation for pi. What we know here is the radius of a plate. The circumference can be found by multiplying diameter by pi. I don't have diameter, but I do have the radius, and I know twice the radius will give me the diameter. So I can change my formula into circumference equals 2 radius times pi. Okay, so what I will need to do is to multiply 2 by 11 and 7/10, and that I'm going to multiply by 3 and 14 hundredths times 3 and 14 hundredths. You can do it using your multiplication skills somewhere in the side, or for this activity, I will just take a calculator to make it quick, and I'll show it to you. So I'm going to multiply 2 by 11 and 7/10, and that is 23 and 4/10. And I'm going to multiply that by 3 and 14 hundredths, and that will be 73 and 476 thousandths. We need to round to the nearest tenth. Tenth is the 4. The digit to the right of the 4 is 7. Since it's greater than 5, we add 1 to the 4 to make it 5. And we don't have to worry about these two numbers anymore. So 73 and 5/10 is going to be my final answer. Equals 73 and 5/10. And that is in centimeters. Okay. Alright, so now we have the same radius of a paper plate, 11 and 7/10 centimeters. We need to find the circumference to the nearest hundredth, and we need to use pi button on the calculator as the approximation for pi. This one is different because we're going to use the actual button on the calculator, you will get a little bit different answer here. So circumference is 2 times 11 and 7/10 times pi on the calculator. Sometimes you will see approximation in terms of pi. You don't need to use the pi on the calculator if you just need to put that letter in. So in this case, when I multiply 2 by 11 and 7/10, you will get 23 and 4/10. What you can do is to write C equals 23 and 4/10 times pi, and that is centimeters. And you can stop here, and most of the time it will be just enough. In this case, in this problem, they're asking us to actually use the button on the calculator. So we will multiply 23.4 by the pi. So 23.4, we are going to multiply, and we are going to use the pi button right here. That's the pi button. We're going to click on the pi, and there you see the symbol pi appears here, and we will click enter, and that is the number that you get. Look how it actually rounded for us. Okay, for 7 that we had before, it already is a 5. 73 and 51 hundredths. We need to round to the nearest hundredths, and because the next number is 3, which is less than 5, we don't have to worry about the rest of it. Okay, so 73 and 51 hundredths. 73 and 51 hundredths centimeters is our final answer in this problem. All right. A circle has a radius of r centimeters and a circumference of c centimeters. Write a formula that expresses the value of c in terms of r and pi. I already showed you that formula before. If we know that circumference is the diameter multiplied by pi, and I know that diameter is 2 times the radius, my formula in terms of radius and pi is going to look like 2 times radius times pi. Okay. The figure below is the shape of a semicircle. A semicircle is an arc right here. That is an arc that is half of a circle. Find the perimeter of the shape. Use 3 and 14 hundredths for pi. This lesson has a lot of new information for you. Here we have a semicircle. This is an arc that is exactly half of a circle. Okay? We need to find the perimeter. So to find the perimeter of this shape, I will have to find what the circumference of half circle is that will give me that arc length. And then to complete the shape, I will need to add that diameter to finish the perimeter. Okay, so what I want to do again is to find the semicircle of to find the circumference of this arc right here. So circumference, and that is the circumference of 1/2 circle. Okay, to find the circumference of half a circle, I'm going to find circumference of a circle and use just half of it. Okay, so circumference equals diameter times pi, but since we are using half of it, we are going to multiply 1/2 of the diameter by pi. And what is half of that diameter? Half of the diameter is the radius, isn't it? So I can find the radius right away because I have the diameter, which is 8. I know half of it will be 4, right? And I can use that to multiply by pi and I will be done. Or you can use the diameter and multiply it by the pi and then take 1/2 of it. Okay, so um, circumference equals 1/2 times diameter, which is 8, and times pi, which is 3 and 1400ths. When I multiply 1/2 by 8, I will get a 4. Okay, and so I'm now multiplying 4 by 3 and 1400ths. 4 times 3 and 1400ths equals 4 times 3 and 1400ths is 12 and 56 hundredths. And that is going to be in meters. All right. That is the end of our lesson 16. You want to know that important vocabulary because we are going to use it all the time. So circle, circle, and I'm going to highlight that for you. Circle is a given point O on the plane and a number where radius is greater than 0. The circle with center O and radius R is the set of all points in the plane whose distance from the point O is equal to R. Okay, so the distance from center to the outside is going to be the same throughout the entire shape, and that is a circle. Radius. Radius is the length of any segment whose endpoints are the center of a circle and the point that lies on the circle. The diameter. Diameter. Diameter of the circle is the length of any segment that passes through the center of the circle whose endpoints lie on the circle. Circumference. Circumference of a circle is the distance around a circle. Okay, pi. Pi, denoted by the Greek letter pi, is the value of the ratio given by the circumference to the diameter. Okay, the most commonly used approximation for pi is the actual letter pi, 3 and 1400ths, or 22/7. Semicircle. Semicircle is half of that circle. So let's see, be a circle with the center O right here, and let A and B be the endpoints of a diameter. A semicircle is the set containing A, B, and all the points that lie in given half plane determined by the segment AB, which is the diameter, that lie on circle C. Okay, so that is going to be half circle. One thing I just realized is that we haven't finished the problem E. We found the circumference of the semicircle, but we haven't found the perimeter. With perimeter, I have to add that missing side. So what I found is 12 and 5600ths, which is that circumference of half a circle. 12 and 5600ths. And to find the perimeter, I need to finish it. I need to add this side. So 12 and 5600ths, we are adding 8, and we get 20 and 56 hundredths meters. Now this problem is complete. I'm sorry about that. Now, if you have any further questions, please do not hesitate to contact me, message me, Otherwise, I will talk to you in the next lesson.